In this lesson, I'll show you how to use the quotient rule to find the derivative of a function. This is part 2 in the series. The question reads, find the derivative of y is equal to 2x to the power of 3 over 4x plus 1. To do this question, you need to define your u and v function. We'll call this top part u and this bottom part v. According to the formula, we need to square the denominator. And for the top part, we need to apply something that looks like the product rule, except we are subtracting the two products. So we keep v the way it is, we find the derivative of u, then we subtract what u is originally from the derivative of v. So let's start by finding the derivative of u and v first. For question 1, the derivative of u, which I'll refer to as u prime, is equal to, and I'll use the power rule, we have 2 times 3 x to the power of 3 minus 1. This results to 6x to the power of 2. That's the derivative of u. And the derivative of v, v prime, 4x plus 1, we take the derivative of this, that gives us simply 4, and the derivative of any constant is 0. So 4 plus 0, or in other words, 4. Let's go ahead and substitute everything we know into this formula. We know what v is, that's 4x plus 1. That part is covered. Now we find out what du of dx is. This is du of dx, and that was equal to 6x squared minus u, which is, according to this, 2x to the power of 3. Put that in brackets, and the derivative of v, which is dv over dx. The derivative was taken relative to x, and we write down 4. Now for the bottom part, we have v to the power of 2, so I'm going to take my v and square it. I don't need to expand, that's good enough. Let's continue. Technically, we have found the derivative, but if we want to simplify the numerator, we can do that as well. So I'm going to simplify the numerator part, and of course, this is equal to y prime, or dy over dx. Let's simplify the top part really quickly. We have 6x squared being multiplied to the two terms. That gives us 24x to the power of 3 plus 6x to the power of 2 minus 8x to the power of 3 over 4x plus 1 to the power of 2 is equal to y prime. That is the answer to question 1. Let's move on to question 2. In question 2, they want us to evaluate s prime at 3 if s is equal to the following expression. Let's go ahead and do this. First, I'll define this part as my u and this part as my v. U is equal to t3 minus 3 to the power of 2. I'll need to use the chain rule for this when I find the derivative. U prime is 2 times this expression, t3 minus 3. 2 minus 1 is simply 1. And the derivative of this inner part is 3t to the power of 2. I used the power rule for both of these terms, and I ended up with that. Now I don't need this 1, so I'm going to erase it. And if I simplify this further, I should end up with 6t to the power of 2 bracket t to the power of 3 minus 3. Now I need to find the derivative of v. Our v was the square root of t plus 1, or t plus 1 to the power of half. We'll need to use the chain rule for this one as well. Bring that 1 over 2 to the bottom, multiply it to t plus 1, and we'll be subtracting 1 from half. That gives us negative half. Finding the derivative of this inside part is simple. We use the power rule and it should give us 1. So our final answer is 1 over 2 times t plus 1 to the power of negative half. Here we have an exponent with a fraction. We can flip the expression t plus 1 so that the negative exponent becomes positive, and then switch it back to radical form. 2 times the square root of t plus 1. We found the derivative of v, which is this part, and we found the derivative of u, which is that part. Now we substitute this into the formula. The formula was keep u the way it is and multiply it by the derivative of v, and then subtract what v is times the derivative of u all over v to the power of 2. So here it is. We have u, which is t to the power of 3 minus 3 to the power of 2, times the derivative of v, which is simply 2t plus 1 square rooted. I multiplied the 2 and I ended up with that. Minus, now we keep this part the same, t plus 1, and I'll bring it back to radical form. There's no need to write it in the other format, times this part, 6t to the power of 2, t to the power of 3 minus 3, all over t plus 1 to the power of half to the power of 2. T plus 1 to the power of half to the power of 2, and look what happens. We can use the power to a power rule for the laws of exponents. Multiply these two numbers out, we end up with 1. T plus 1 is simply that. And this is equal to s prime. Now we need to find out what s at 3 is. So we will substitute 3 wherever you see a t. If you do that part correctly, s at 3, you should end up with 612. And there you have it. That is how to use the quotient rule to find the derivative.